Hello students, welcome to this video on opener oxidation. Opener oxidation is a mild and selective method for oxidizing secondary alcohols to their corresponding ketones. So it basically involves using aluminum isopropoxide in the presence of excess of ketone. Basically it will be acetone to convert secondary alcohols to their corresponding ketones. Now, if you look at this reaction, you can see that this is a reversible reaction, which means that the ketone which is formed can be reduced back to their corresponding secondary alcohols using the same catalyst. So the forward reaction, which is oxidation of the secondary alcohol to the ketone, is called as opener oxidation, whereas the reversible reaction Okay, so the reversible reaction wherein the ketone in the presence of excess of secondary alcohol and in the presence of aluminum isopropoxide catalyst is converted back into its corresponding secondary alcohol. It's called as Mervin-Pondroff-Verley reduction. So opener oxidation and Mervin-Pondroff-Verley reduction are competing mechanisms, and the reaction conditions can be controlled to forward one reaction. So opener oxidation is a mild and selective method. So it's quite a useful method for oxidation of secondary alcohol, especially in the presence of other functional groups, readily oxidizable functional groups. Okay, and basically it is mostly used for the oxidation of secondary alcohols, not for primary alcohols, because the aldehydes which will be formed as a result of opener oxidation because of the presence of aluminum isopropoxide catalyst can undergo Claisen condensation, and it may lead to formation of several byproducts. So opener oxidation is generally used for the oxidation of secondary alcohols, not for primary alcohols. Now let us see the mechanism of opener oxidation. The first step involves coordination of the secondary alcohol with aluminum. Aluminum, you know, it's a Lewis acid. It has an empty orbital, which can accommodate a pair of electrons from the secondary alcoholic oxygen. Okay, and this leads to formation of a complex, and this complex will further coordinate uh, with the ketone, which is acetone, to form a six-membered chair-like transition state. And in this six-membered chair-like transition state, you can see a hydride transfer occurring. Hydride transfer where? From the secondary alcoholic alkoxy group to the ketone. Okay, so this is how oxidation is also loss of hydrogen. So you can see that the hydrogen being taken away from the secondary alcohol group and transferred to the keto group. So finally, once this transfer take place, this will be cleaved. Now you can get a ketone with the catalyst which is being regenerated here. Okay, so the first step is formation of a coordination complex, and the coordination complex further reacts with acetone to form a six-member chair-like transition state, wherein the hydride is transferred by the aluminum from the alcoholic the secondary alcohol to the ketone. Okay, finally giving you the product. Now if you look at the applications of opener oxidation, now you can see that codeine, here you can see this is a secondary alcohol. Codeine can be converted into codinone using aluminum isopropoxide catalyst, and the ketone used here will be cyclohexanone. Similarly, several steroidal molecules, for example, pregnenolone, can be converted into progesterone using Oppenauer oxidation method. Cholesterol can be converted into cholestyramine using Oppenauer oxidation method.